Yes, let us discuss about the projection of a directed line. Projection of a directed line. Yes. You take these 2 points. A and B are the 2 points. L be the directed line. You take this as a C. You take a L and M are the projections of A and B on the line L. Now, this line makes an angle theta with this. If it is extended, this is also theta. Now, the length of AC is same as the length of what? LM. Let capital A comma B be the 2 points and R is the distance between them. You take this one as R. This is R. Now, the projection of A comma B on the directed line L, BL comma M, and it makes an angle theta. Right? Now I want to find out the projection of this. So now I can write, let A comma B be 2 points and L be the directed line, and it makes, and theta be the angle made by AB with the line L. Yes, L. Let L comma M be the projections of capital A comma B on the line L, and the distance between A comma B 2 points is what? R. From since AC is equal to LM, I can write from the triangle, ACB, what is cos theta? Cos theta is nothing but AC by R is same as LM by R. So therefore I can write LM is equal to R into cos theta is same as AB into cos theta. So therefore I can write the projection of AB on the line L is equal to AB into cos theta or R into cos theta. Yes, there comes about the discussion, that is argument. If theta is acute, LM is the projection of AB on the line L. If theta is obtuse, minus LM is the what? Projection of AB on the line L. If theta is acute, LM is the projection of AB on L. If theta is obtuse, minus LM is the projection of AB on the line L. One is in positive direction, other one is in what? Negative direction. Followed? Right. So therefore, this is about the projection of the line segment AB on the directed line L is given to be AB into cos theta is nothing but a projection of AB on the line L. Next comes about the projection of line segment joining A of x1, y1, z1, B of x2, y2, z2 on the line having DCS L, M, N is L into x2 minus x1, M into y2 minus y1, N into z2 minus z1. Okay, let us consider A as x1, y1, z1. You take x2, y2, z2 are the 2 points. Okay, this is a line having the what? DCS L, M, N. I start like this. So now coming this one is, proof of this one is, DRS of AB bar is given by x2 minus x1, y2 minus y1, z2 minus z1. Okay, now let AB is equal to R, length of AB is R, therefore DCS of AB bar is given by x2 minus x1 by R, y2 minus y1 by R, z2 minus z1 by R. Now I can write this one as, so let theta be an angle between AB and the line having the DCS L, M, N is cos theta is equal to L into x2 minus x1 by R, M into y2 minus y1 by R, by R. Therefore, cross multiply, this is R into cos theta is equal to L into x2 minus x1, M into y2 minus y1, N into z2 minus z1. Yes, as we have discussed just now, the projection of AB on the line L having a DCS L, M, N is given by AB into cos theta, R cos theta. R is nothing but AB. So therefore, what is a R cos theta? R cos theta is nothing but AB cos theta. I can write AB cos theta is equal to L into x2 minus x1, M into y2 minus y1, N into z2 minus z1. What is this? This is nothing but projection of AB on the line L. This is equal to, yes, L into x2 minus x1, M into y2 minus y1, N into z2 minus z1. So hereafter, the projection of the line segment joining A of x1, y1, z1, B of x2, y2, z2 on the line having a DCS L, M, N is given by, that is L into x2 minus x1, M into y2 minus y1, N into z2 minus z1. Yes, let us recall this concept for some vivid example as a decide. Yes, let us recall the concept of projection of line AB on the line L having a DCS L, M, N. Now he is asking, he has given the 4 points A, B, C, D having the respective coordinates. I want to find out the projection of AB on CD. AB must have the direction ratios, CD must have a direction cosines. So therefore, now I will write, now this one is a DRS of AB bar. DRS of AB bar, x1, y1, z1, x2, y2, z2, x2 minus x1 minus 2, y2 minus y1, 1. This is 2. Followed? Next, you take this point as x2 minus x1, y2 minus y1, z2 minus z1. Followed? Now I want to find out DRS of CD bar. DRS of CD bar. Now, DRS of CD bar is, there was 0 minus 4, minus 4, 1 this is minus 2, this is what? Minus 3. This is same as 4, 2, 3. Yes, when A, B, C are the DRS of a line, we know that KA, KB, KC, A by K, B by K, C by K are also DRS of the same line where K belongs to R. Followed, when minus 4, minus 2, minus 3 are the DRS of a line, it is quite obvious, that goes without saying, 4, 2, 3 is also what? DRS of that line. Let us find out its direction cosines. What's the length of this one is? DCS of CD bar is nothing but 16 plus 4, 20, 29. Therefore, 4 by root 29, 2 by root 29, 3 by root 29. You take this one as LMN. Followed? LMN. So therefore, I can write this one as x2 minus x1. I want the projection of AB bar on CD bar is given by x2 minus x1 into L, y2 minus y1 into M, z2 minus z1 into N. Therefore, this is nothing but, yes, that is now minus 2 into 4 by root 29. Next, minus, that is A, 1 into 2 by root 29. Next, 2 into 3 square root of 29. So therefore, this is nothing but root 29 minus 8 plus 2 plus 6. Okay. Therefore, this is equal to how much? 0. Okay. Note, if I select a what? A space x, y, z with respect to origin. If I select a point, say for example, this is AB, let A of x1, y1, z1, B of x2, y2, z2 be 2 points, then first one is length of the projection of AB on x-axis, x, y, z-axis is dash. Next, second one is on yz plane is dash. Third one is zx plane is dash. Fourth one is xy plane is dash. The length of the projection of AB on x-axis, y and z-axis dash. Let us take the proof of this one is the projection of AB, okay, projection of A of x1, y1, z1, B of x2, y2, z2 on first one x-axis B, L is equal to x1, 0, 0 and M is equal to x2, 0, 0. Length is asking, therefore length is equal to modulus of x2 minus x1. Second one on y-axis, that is a n is equal to 0, y1, 0. r is equal to 0 comma, that is y2 comma 0. So therefore now nm is that is nr is equal to, that is modulus of y2 minus y1. Then third one, on z-axis, z-axis equal to z-axis, I can write s is equal to 0 comma 0 comma z1. So the projection of A on x-axis x1 comma 0 comma 0, projection of B on x-axis 0 comma y, that is x2 comma 0 comma 0. Similarly, you can go for y-axis and as well as z-axis in a cyclic order. So therefore, S and T you take, this becomes 0 comma 0 comma z2. Now therefore, the length of the projection of AB on z-axis is modulus of z2 minus z1. These are the lengths of the projection of line joining of the 2 points A of x1, y1, z1, B of x2, y2 on the coordinate axis. In the same fashion, I can go for the 3 coordinate planes. How many coordinate planes? 3, xy, yz, z-axis respectively. These are the coordinate planes. Let us see how you can find out on this. So projection of A of x1, y1, z1, B of x2, y2, z2 on xy plane. Okay, now let L of x1 comma y1 comma 0, M of x2 comma y2 comma 0 be the projection of A comma B on xy plane. It is quite obvious. In xy plane, z coordinate is equal to 0. In yz plane, x coordinate is equal to 0. In z-axis plane, y coordinate is equal to 0. That goes without saying. So therefore, let us find out the length of the projection. Length of the projection is given to be, yes, Lm. Apply the distance formula. This becomes square root of x1 minus x2 whole square, y1 minus y2 whole square. Similarly, the length of the projection on, this is on projection on xy plane. This is xy plane, right? Plane. On yz plane. The second one is on yz plane. Yz plane, I can write this one as, that is y1 minus y2 whole square, z1 minus z2 whole square. Next, third one is on zx plane. I can write this one as x1 minus x2 whole square, z1 minus z2 whole square. These are the lengths of the projection of the line segment joining A of x1, y1, z1, B of x2, y2, z2 on xy plane, yz plane, zx plane. Okay. Now, the projection of a line of length d on the coordinate axis are d1, d2, d3, then d square is equal to d1 square plus d2 square plus d3 square. Before starting of this one, just now we had a discussion about the projection of AB, the length of the projection of AB on x-axis, x2 minus x1 modulus. That one is taken as d1. And projection of A of line joining of 2 points A of x1, y1, z1, B of x2, y2, z2 on y-axis, y2 minus y1 taken as d2. Next, the projection of AB on z-axis is modulus of z1 minus z2. Okay, now I select, now in space, you take this as x-axis, y-axis, this is z-axis. You take a point x1, y1, z1, this is B of x2, y2, z2. The length of this one is d. Okay, d. Now I start. The proof of this one is, let d be the length of the line AB joining A of x1, y1, z1, b of x2, y2, z2. Then AB is equal to D is equal to square root of, okay, square root of, I can write this one as x2 minus x1 whole square, y2 minus y1 whole square, plus z2 minus z1 whole square. This is D. Now, projection of A of x1, y1, z1, B of x2, y2, z2 on x-axis is L of x1, 0, 0, M of x2, 0, 0. So therefore, now LM is equal to D2 is equal to, that is D1 is equal to, D1 is the length of the projection of AB on x-axis, that is LM. Apply distance formula. This becomes modulus of x1 minus x2 whole square plus 0, which implies that is LM is equal to D1 is equal to modulus of x1 minus x2. Similarly, on y-axis, D2 is equal to modulus of y1 minus y2. On z-axis, D3 is equal to modulus of z1 minus z2. Followed? Okay. Now I want to find out. Now add up. Squaring and adding. D1 square plus D2 square plus D3 square is equal to, I can write this one as x1 minus x2 whole square, y1 minus y2 whole square, z1 minus z2 whole square. Correct? Followed? So therefore, now this is nothing but d1 square, d2 square, d3 square. This is nothing but d square. Why? Because what is d? D is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Followed? So therefore, now remember, this is one of the important property. Yes, what is that? If the projection of a line of length d on the coordinate axis are d1, d2, d3, then coordinate axis, next you come across coordinate planes, then d square is equal to d1 square plus d2 square plus d3 square. Now once again, A of x1, y1, z1, B of x2, y2, z2 be the what? 2 points. The line segment joining of AB, its length be, let it be d. So therefore, now what I want, right, is d is equal to, that is, apply the distance formula. Next, the projection of A, B on x-axis, B, L, M. On x-axis, y and z coordinates of are what? 0. So therefore, I got it as, that is L as this, M as this, apply a distance formula. This can be taken as D1. In the same fashion, I can also write on y-axis, D2 is equal to modulus of y2 minus y1 or y1 minus y2. It makes no difference. On z-axis, z1 minus z2. So therefore, squaring and adding, that leads to what? It's a d square. D square is nothing but what? x1 minus x2 whole square, y1 minus y2 whole square, z1 minus z2 whole square. Sorry, here x1 minus x2, here x2 minus x1 whole square can be written as a minus b whole square is same as what? B minus a whole square. The projections of the line segment of a line of length d on the coordinate axis are, let us take 3, 4, 5. Then the length of the line segment, then the length of the line segment, that is d is equal to dash. Instead of taking x, instead of giving x1, y1, z1, x2, y2, z, he has given the what? Projections. The projections of a line of length d on the coordinate axis are 3, 4, 5. Then the length of the line segment d is dash. Now on the coordinate axis, this is coordinate axis, I can write the solution of this one is, since d square is equal to d1 square plus d2 square plus d3 square. Followed? Therefore, d square is equal to 9 plus 16 plus 25. Therefore, d square is equal to what? 50. Therefore, d is equal to, now this is nothing but 5 root 2 is the length of the line segment. Length of the line segment having the projections on the coordinate axis respectively are 3, 4, 5. Its length is given to be what? 5 root 2. Okay. The projection of a line of length d on the coordinate planes, on the coordinate planes b d1, d2, d3, then the length of the length of line segment is dash, or d is equal to dash, segment d is equal to dash. Yes, now the line AB, that is line segment AB, now it is defined in space. Let us consider now AB is in space. Let us consider projection of A and B on XY plane is, let it be L, M. If I take this as L here, this is L, this becomes x1, y1, 0. M as what? x2, y2, 0. Next, the projection of A, B on YZ plane, let it be n of 0, y1, z1. Next, O of, that is M and O, P, you take this as P, as what? 0, y2, z2. Next, projection of AB on ZX plane, Q of what? x1, 0, z1, or as what? x2, 0, z2, right? So therefore, now what I do is let d be the length of line segment AB joining A of x1, y1, z1, B of x2, y2, z2. Therefore, D is equal to, AB is equal to square root of x2 minus x1 whole square, z2 minus z1 whole square. Now, this is the what? Length of the line segment. Let L of x1, y1, 0, M of x2, y2, 0 be the projections of A, B on xy plane. So therefore, now let us take this one as, okay, xy plane. Now coming to xy plane. So therefore, D2 is equal to, LM is equal to the length of the projection of AB on xy plane. Therefore, D2 is equal to distance between LM you apply square root of x1 minus x2 whole square, y1 minus y2 whole square. Now, that is, you take this as a D1, you take this as a D2. Similarly, D2 is equal to, you take this as a NP. NP is nothing but the length of the projection of AB on YZ plane. YZ plane. This D2 is nothing but y1 minus y2 whole square, z1 minus z2 whole square, right? Now this is nothing but, next D3 is equal to, yes come on, D3 is equal to QR is nothing but the length of the projection of AB on ZX plane. Therefore, I can write D3 is equal to square root of x1 minus x2 whole square or x2 minus x1 whole square, as you please. Now this becomes z1 minus z2 whole square. Come on, squaring and adding, this becomes d1 square, d2 square, d3 square, d1 square plus d2 square plus d3 square. Now add up this. This becomes x1 minus x2 whole square. Here also x1 minus x2 whole square. It comes as 2 into x1 minus x2 whole square plus here also y1 minus y2 whole square. Here also comes y1 minus y2 whole square. It is also 2 times of y1 minus y2 whole square. Next, z1 minus z2 whole square. Here also z1 minus z2 whole square. Now you take this point as z1 minus z2 whole square. Now I can write d1 square plus d2 square plus d3 square into, that is a d square. Why? That is d is nothing but what? Square root of x2 minus x1 whole square or yx1 minus x2 whole square, y1 minus y2 whole square or z1 minus z2 whole square. This is same as d square. So therefore hereafter, remember if the projections of a line of length d on the coordinate planes b at d1, d2, d3, then the length of the line segment d is given to be what? It is 2d square is equal to d1 square plus d2 square plus d3 square. If it is on coordinate axis, d square is equal to d1 square plus d2 square plus d3 square. Followed? So therefore, once again you see the projection of AB on this is LM and projection of this one is NP. Projection of AB on this is what? QR. Find out AB is nothing but square root of what? x2 minus, that is x2 minus x1 whole square plus y2 minus 1 whole square plus z2 minus 1 whole square, z2 minus z1 whole square is nothing but a d. Now on xy plane LM, on yz plane NP, on zx plane what? QR. Okay, now you take this as d1 is equal to distance between what? LM, apply x1 minus x2 whole square, y1 minus y2 whole square. Our d2 is nothing but y1 minus y2 whole square plus z1 minus z2 whole square. And d3 is the length of the projection of AB on zx plane, apply distance x1 minus x2 whole square, z1 minus z2 whole square. Squaring and adding, that gives what? d1 square plus d2 square plus d3 square is equal to 2 times of length of the line segment T, that is 2d square. On coordinate axis, d1 square plus d2 square plus d3 square is equal to d square. On coordinate planes, d1 square plus d2 square plus d3 square is equal to 2d squared. Followed? The projection of a line segment on the coordinate planes are 3, 4, 12, then the length of the line segment is dash. The projection of a line segment on the coordinate planes means, now I take, let d be the length of the line segment and d1, d2, d3 be the projections of a line segment on the coordinate planes where d1 is equal to 3, d2 is equal to 4, d3 is equal to 12. Since on coordinate planes 2d square is equal to d1 square plus d2 square plus d3 square. Okay, if it is coordinate axis, d square. Now I want to find out d. d1 is given to be what? 3, 9. It's a 16. It's a 144. Now this is 25. Therefore, 2d square is equal to 169. So therefore, now I can write d is equal to 13 by root 2 is the answer. That's right. This is the length of the line segment having the projections on the coordinate planes are 3, 4, 12. Then the length of the line segment is d is equal to 13 by root 2. Right? Now, look at the projection of a line segment having a length 13 on xy, yz planes are 5, 4, root 10. Respectively, the projection of a line segment on zx plane is dash. Now we know that let d be the length of the line segment having projections d1, d2, d3 on xy, yz and zx plane respectively, then 2d squared is equal to d1 square plus d2 square plus d3 square. But d is equal to how much? 13 is given. Next, d1 is equal to how much? 5. d2 is equal to how much? 4 root 10. But d3 is the question mark we are supposed to find out. Take all these values, you substitute here. So therefore, 2 into 13 whole square, 5 whole square, next 4 root 10 whole square, it's a d3 square. Now I can write 2 into 169. This is nothing but 25. This is 16 into 10 plus d3 square. Now this becomes 338. 25 plus 160 plus d3 square. Now here 338 is equal to 160, 320, 18. Okay, 338. This is 185 plus d3 square. Now this d3 square is equal to 338 minus 185. Therefore, d3 is equal to square root of 338 minus 185. How much you get? That can be taken as the projection of a line segment having the length 13, despite this having the projections on xy plane as 5, yz plane as 4 root 10 is. Now I want to find out the projection of a line segment on zx plane. So now let d be the length of the line segment having the projections d1, d2, d3 on x, y, z, xy, yz, next zx plane respectively. We know that 2d square is equal to d1 square plus d2 square plus d3 square, but What he has given? D is given, D1 is given, D2 is given, D3 is not given. Substitute the real values. That gives D3 is equal to root 338 minus 185 is the required answer. This is all about how we come across about the projections of the line segment. The projections of the line segment means when let D be the length of the line segment, having the projections on x, y, z axis d1, d2, d3 is given by d square is equal to d1 square plus d2 square plus d3 square on what? Coordinate planes as what? d1, d2, d3 given by 2d square is equal to d1 square plus d2 square plus d3 square. Thank you.